Thank you for that very loving introduction. It's really nice to be here. So yeah, I'm talking about validating big data and ML pipelines. I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist, which is really convenient in the mornings when life is a little hazy. I'm on the Apache Spark PMC, which is all kinds of fun. I'm a developer advocate at Google, which is really nice because it means that I get paid to work on open source, and I get paid to come and give talks like these, which is really nice. I've worked at a whole bunch of other places as well. I'm a co-author of 2 books on Spark. In the second one, I learned that you can negotiate terms with publishers, so I think it's a much better book. The royalties are just that much higher. The content, I don't know if it's any better, but I do get paid more. You can follow me on Twitter or on SlideShare. And if anyone is interested in learning more about how large open source projects like Spark do their code reviews and how we merge PRs, decide on issues, I've started doing code review live streams, and I broadcast them to Twitch and YouTube. I think they're kind of fun, and it's more fun when people join and ask questions, because otherwise I just have to sort of come up with shit as I'm going. And my talks are normally recorded on YouTube, and I have this playlist here. And if you have any feedback on this talk, really pretty much anything except maybe how awesome my dinosaur dress is, I already know my dinosaur dress is amazing. I would love your feedback, and that would be appreciated. Oh wow, there's so many people showing up. In addition to who I am professionally, I'm trans, queer, Canadian, in America on a work visa, which is a really exciting adventure right now, as they debate whether or not they want to keep my work visa. And so that's really fun. And I'm part of the leather community. And this is not directly related to validating big data pipelines. There is no secret Canadian garbage collector that we've been hiding from you. We all feel the pain of Spark's out-of-memory exceptions, and if I could take that away from you, I would. But I think it's important that we acknowledge our differences and we try and work with people from different communities, especially for those of us who are building ML tools. Otherwise, we'll just build the same shitty tools with big data faster, and we can burn the world down, and that'll be kind of depressing. But if we actually have sort of diverse viewpoints in the room, I think we can make better tools and better software. Okay, and I also, if you could laugh at my jokes, I would appreciate it greatly. My parents are here, all the way from Canada, and this is the first talk of mine they've ever seen. So if you could pretend that this is good, I would be just very, very happy. So okay, we're gonna talk about why my employer cares about this, because sometimes I give talks and people are like, I get why you do this, but why does Google pay you to do this? Some of my assumptions about who you all are. We'll do a really quick sort of side quest into property testing. We'll talk about what validation is and why you should care about it, and how to make simple validation rules and our current limitations around validation rules. And then we'll talk about specific things that we can do if we're building ML pipelines. How many people are building or are interested in building ML pipelines with Spark? Cool, I'm glad I added that. Good job. Okay, cool. And I promise at least one picture of a cat, and that is one thing that I think I can over-deliver on. So why does my employer care? Ooh, I misspelled the word hosted. I can edit it before we upload the slides, so that's great. I'm glad it's not being recorded live. But we have a hosted Spark Hadoop solution called Dataproc. We also have hosted pipeline management tools. And we also want to be good open source community members, although admittedly fuzzy feelings do not pay my salary. And this is all good. There are probably other reasons why my employer cares about this, but I don't go to all of the meetings that I'm invited to. There's far too many of them. And so there's probably other solid reasons that we care about this besides just selling you things. But that part is certainly non-trivial influence. So I'm hoping you're nice people. And I'm really hoping that you're familiar with one of Scala, Java, or Python. There are no examples in R because I don't know R. If you do know R and you think this stuff is cool, I would love to work with you to make validation tools for R. I just don't have the background to do it. And I'm hoping that maybe you want to make models or software better. If you don't care, maybe I can just appeal to your desire to not get fired, and we can go from there. So actually, this part is probably going to be really depressing, but I'm going to ask it anyways. How many people test their pipelines? Thank God, but there's a lot of people who just did not raise their hands, and I'm very worried that you might work in finance, because we're in London. I'm just going to take a picture of the audience for my boss so that he keeps paying my salary. So we should test to be better people, save money. Having our ML jobs fail on hour 26 is a really expensive thing. And just on a personal level, I don't like long development cycles. I like fast turnarounds. If I have to wait for my stuff to fail in production on the failboat, it's not going to be very happy. For those of you who aren't testing, please, for the love of God, test your software. Okay. Why should we validate? So how many of you that do test your software believe your tests cover all of the possible cases your software is going to encounter? There is one very optimistic person. And that's legit. Maybe your tests are truly amazing. But for the rest of us, our tests often get sort of second shift work, right? We got it done, and then we added some tests, and then, hey, it's cool. I get paid either way. And the thing is, the real world is really creative at failing. There's this wonderful Call Me Maybe blog series where our data sources can just lose data. It's great. Someone on another field, if we work with teams, can change our data for us very helpfully. They might forget to tell us that they made these changes, and then our stuff will start to fail. And at the end of the day, the real world is just more creative than I am. And we're all eventually going to get on the failboat. And the best thing we can do is realize that we're on the failboat before our customers do, and try and get on a different boat. And that's what we can try and do with validation. 37% of people automatically deploy the results of their Spark jobs to production. If you're in that 37%, I really hope you have good tests. I hope you validate as well. This means that there's no chance to catch errors if we just run this. Relatedly, 14.7% of people have had a serious production outage caused by a Spark job. And in this case, what I interpret serious to mean is I had to update my resume and go look for a new job. 33% have had an outage, and it wasn't serious enough that they had to find a new job, but there were some very upset people to deal with the following day. And you don't want to be in either of those groups. And 52% are either really lucky or in the proof of concept phase. If you're in the proof of concept phase, that's great, but I don't want to bet my job on my luck. H-1B visas may not be as easily transferable in the future. So let's try and not get fired. So why don't we test? For those of you who didn't raise your hands for testing, it's okay, I understand. Testing is hard. It's a lot of work. It's not a lot of fun. And testing distributed systems is especially painful. The other reason is that notebooks are so much fun. But I don't know where to put my tests anymore. And I think I don't want to be down on notebooks. But I think even if you write notebooks, you still need tests. You can convert your IPython notebook to a Py file in your CI system and then run your tests against that. You can still test notebooks. There are very valid options. And so for validation, I think it's more common not to validate our jobs. And I think it's because we already tested our code. I spent like 4 hours that one time. The test suite have at least 20% coverage. We're good. What could go wrong? And the other part of why we don't validate is very similar to why we don't test. Getting our metrics is really challenging, right? It's not like I have a single microservice. I can just pull that thing from metrics. It'll be uniform, and I can validate that it's working. The other part is, and we all love Spark's ability to recover from failure, But knowing the difference between Spark recovering from failure and actual failures in my code can get a little bit complicated. And this can get a little bit fuzzy with our metrics. So the audio is being recorded, right? I think. I'm pretty sure the audio is being recorded, so the personal stories will not have any company names associated with them, but you can read them here. But essentially, I have, at various jobs with various data pipelines, screwed up really badly. Now, I haven't had to quit, or resign, that's the polite term, or been asked to resign in exchange for money to shut up. But it's always been a little dicey. The one time when I cost my employer a few $1 million was a really shitty week for me. I imagine it was a shittier week for my boss, and the shareholders didn't notice. But nonetheless, you don't want to be that person. That's probably not going to be the year that you get promoted. That's just not going to work out so well. One time, and a low point in my career was we built a recommender system, and it started to recommend illegal content. Thankfully, we caught it by a manual spot check. But if that had made it into actual production and recommended it to real humans, I probably would have left this industry to become like an alpaca farmer, right? And alpacas are cute, but you probably don't want to burn yourself out doing this stuff, right? And the other time is more funny. I like coffee shops, and so I deployed a new model. It worked really well for coffee shops, and I only tested it on coffee shops because all of my test sets were about like, I want to get coffee. But then it turns out that like a search for steak should not return Starbucks. And so, you know, it's not so great. Okay, so we can have bad things happen if we don't do this. So hopefully I've convinced you that this is important enough, you should not leave, and we can make this stuff happen. So how do people test their pipelines? A lot of people, 60% of people in fact, make their test data by hand. And if you're making your test data by hand, there's a really good chance that your production data is going to have some differences from your test data, right? You're just not as creative. People who sample production data, that's great. If your sample happens to be large enough to catch all of your edge cases, you're good. And the small percentage of people who can test on their entire production data are very lucky people or people who are using Spark that don't need it. And that's great. What else can we do? How many people here use property testing? That's like 8 people. Okay, for the rest of you, I would encourage you to take a look at property testing. It's really cool, and it allows us to not spend all of our time trying to come up with different ways that our data could go wrong. Instead, we give that to a computer program, and the computer program will spend all of its time trying to figure out ways to make our code fail. And so here is a simple 1 million entries. Dr. Evil was not as popular here. Okay. But we can see here we have some important business logic, and all we're saying about this is that my important business logic should not lose any records, right? This is a relatively simple test, but I have written code that will fail this test, and that's because the property generators are just really devious. They will do things that the real world will do for you. They'll generate null records. They'll generate partitions that are empty. So if you have a map partitions that assumes that there's data in every partition, it will fail. And it will actually catch a surprisingly amount of errors for what is very simple code. Now, obviously not every transformation will have this property, right? Sometimes if we're filtering out, for example, bad customers, or if we only want to make recommendations to certain customers, we would have different properties here, and we can specify them there. Clicky thing, stop clicking. Oh, right, and this is kind of slow. There's some hacks you can do to make it faster. I'll post the slides later. Don't worry about that. So let's focus on validation, which is the main reason that y'all are here. So how do we actually go ahead and validate our job? So I want to be clear, validation isn't the thing that you start doing on your brand new pipeline, right? If you start doing that, it's not really going to tell you a lot. I think that validation is a great thing that we do while we're productionizing our pipeline. We need to make it work first, right? There is no replacement for, at least initially, looking at our model and manually inspecting things, seeing if it has these sanity checks passed. Hopefully you have some other tests as well, but we can't do this every time, right? Nowadays, we don't have months to push new things into production. People want things fast, and they're not really willing to pay for it. But since they sign our paychecks, we have to deliver it to them anyways. So I'm curious, how many people have code that looks something like this in one of their pipelines? Okay, there's like 5 people. Do the rest of you just have really reliable data sources? Okay, let's do this the other way, because obviously some people have fallen asleep, and that's fine. How many people do not have to throw invalid records from their data sources? Okay, that's no one. Most people are asleep, so it's debatable as to whether or not there is anyone. But essentially, we will all most likely have some bad records. And if we stopped our entire pipeline every time we encountered a single bad record, that's a really good way to never finish. By the time you've gotten it working on last week's data, this week's data has showed up and it has new invalid records. And that's okay, right? How many people work with JSON data? Okay, that's a lot of you. And if you work with JSON data, there's a really good chance that some of your stuff is just going to be junk. And that's fine. There's nothing wrong with that, and that's totally expected. So we should throw out our records which are bad, because otherwise we would just have this like terrible mess of processing code. The only problem is, eventually, we're going to run this, and someone's going to change the meaning of a field, or something's going to go away, and instead of having 90% valid records and 10% invalid records, it's going to flip on us, right? And then if we start to build recommendation models with maybe only 10% of our user base, it might say that like the only people that we know about are people who really love cake. And all of our recommendations are going to be cake, because that's a field which has to be populated. But it turns out that maybe not everyone in the world loves chocolate cake. And so that's going to be kind of sad. So we want to make sure that when we run code like this, we actually count and double check. So here, what we're saying is, for example, we'll do these 2 filters. And if the amount of valid data we have is less than the amount of bad data we have, we should do something about that. Most likely what we should do is just use yesterday's model until I wake up and have a chance to take a look at my data sources and see what's going on. That being said, doing that is kind of sad. Okay, right, and we could trigger a page here. I don't want to, because I don't like waking up at 2 a.m. That's not fun. And that's less fun, right? That code is less nice to write. I can't chain together all of my flat maps and pretend I'm writing functional code, and I'm blocking on the driver, and that's going to slow my job down. And it breaks a bunch of optimizations. So instead, we can use counters. And Spark has some built-in counters for things that we can take a look at. And we can also add our own counters for additional properties that we care about. And we can pretend that we're writing functional code even though we're mutating state. But it's okay because it's hidden inside of a black box, and that's really the best that I can do. And there's a Jira issue if anyone's really interested in seeing sort of the downsides to this approach. Yes, so while we can use these to solve the problems, they come at a cost, right? And so they sort of steal our lunch money occasionally. Or as the famous regular expression saying goes, I have 99 problems, I'll solve it with a regular expression, and now I have an uncountable number of problems. This is very similar with accumulators. So we can get some counters for free, right? One of the things that could be a good sign about if our job is behaving similarly to previously is, does my distribution of duration look similar, right? If I have a pipeline which used to take hours to run that is now completing in minutes, the option is I'm an excellent programmer, or my data is garbage. And most of the times, it's not number one, at least not for me. Maybe you have a better success rate. And there are other metrics here that we can look at too, right? We can see the amount of shuffling, and we can see our input, and things like this. So if we go from terabytes to kilobytes, that's also probably not a great sign. And so we can go back to our previous example, where we have our own counters, and we keep track of the number of records we accept and reject. And then we put our special business logic in the middle, and then very, very near the end, we figure out whether or not, this is looking like what we would expect it to look like. So there's some problems with accumulators in Spark. How many people use accumulators with Spark? It's a good number of people, and one person who's like, I sort of use them, but I don't really. You and I should talk later, but anyways. It turns out that accumulators, even though we're using it here to track a data property, aren't great for tracking data properties. Because when Spark re-executes, it might add it multiple times. And so that's why we keep track of the number of successes and failures and compute them as a ratio. Because if we kept track of the number of failures and Spark re-executed one partition like 10 times, we might just have 10 times the number of failures, but not 10 times the number of successes. And then comparing the absolute numbers wouldn't be great. Okay, so what do people do in practice? It turns out that most people, according to a depressing survey I ran, just check the execution time and record counts. There's a tool that you can use to write more complex rules. You can take your property tests and turn them into validation rules, right? We can think of our property tests as specifying invariants about our code, and then those invariants should hold true at runtime as well. And mostly, I think, we should use historic data. And that is the idea that today should look kind of like yesterday. Or if I'm in a cyclic business, today should look kind of like last year plus some percentage of growth. And that's good. I'm low on time, so we're going to go through the ML stuff super quickly. Because this timer says I have 3 minutes, but this timer says I have 8. Input schema validation, super important. You should totally do that. Lots of different options. We looked at 2 of them in the code right there. This is kind of how you can write your rules. You write, bad and good, and you keep track. Don't throw an actual exception. If you throw an exception, you're going to lose your data, and you can't just come back to it and take a look at it. Instead, leave a marker that indicates to your pipeline management tool not to continue so that you can go in and debug this issue. And if you want, you could even leave your cluster up, depending on how much money you have to throw at this problem. Turn on dynamic allocation, but then you can go and sort of poke around on it live, and that's kind of useful. You can use Spark's built-in rules, like the number of records we've read. And another thing which you wouldn't really normally do in the same job, but you would do it in a sort of parallel job, is you can look at the percent of data that's changed. And you can do this on either your inputs or your outputs. And the idea is the amount of my inputs that are changing from week to week should be pretty similar. But if I see huge spikes on either my inputs or outputs being not the same, I should probably have an engineer look at this before we push our recommendations into production. And we can do this just with joins, like full outer joins, and just saying this is the percentage of mismatched records I'm expecting. But you probably don't do that as your main pipeline, and you probably want to do that in a second job that can run parallel on less expensive preemptible instances. Software can change too. Some of them for the better, right? Like the new versions of Spark are always better than the old ones. We never introduce regressions. You should just upgrade without testing, right? That's a great idea. Okay, oh, I've got 5 minutes. I don't know why this counter says I have 1. Oh well, whatever. I'll go with yours. I like your number more. But okay, so our software is going to change too. And if any of you have like some spare time or can trick your boss into thinking it's really important, we are in the middle of the Spark 2.4 release cycle. One of the things which I would love for people to do is run your pipelines on our release candidates and see if it looks the same. You should do this eventually once we're released anyways, but if you do it during the release candidate process, you can tell us if we broke your shit so we fix it. And if you wait until after, we might fix it if it's really important. But if it's your special use case, the chances of it being fixed are a lot smaller. But if you tell us earlier rather than later, we can really address this. This is also part of me trying to get you to do my job for me, so I understand the lack of enthusiasm. But I would really appreciate it. I am very lazy. So the other part is you're going to change your own code too, right? And when you change your own pipeline, you should know what you're expecting to be different. You still have your code for your old pipeline. You should run them against each other and see if they look the same. Once again, joins are amazing. You can do this really easily. And there was this really depressing PyData London talk about how this can impact machine learning models. She ran across scikit-learn, not Spark admittedly, the same code with different scikit-learn releases. And there were times when the model just did not produce any correct results. And there were no code changes on her part, just library upgrades, right? Just making changes to your underlying libraries can have huge changes. And we try not to do that in Spark. We try really hard, but it's open source. It's not perfect, right? Without you helping us catch these errors, we're just going to notice the ones that affect us and our customers. So you need to chip in here. Okay, so let's talk about ML. So one of the things that isn't so great with ML is we can't really look at the size of our outputs, right? Our model from day to day isn't going to change in size. I have the same number of weights in my linear regression model today and yesterday, but I could still have really different results coming out of it. So traditionally, humans updated their models, they went through a runbook, and then they pressed deploy. In practice, humans never bothered to write the runbook on how to update their models. Every so often, they would kind of do it when someone yelled at them, and they would press deploy and just hope that it worked. But we can do better than that. We can schedule our jobs to update our models. We can have a workflow tool, notice we have a new model, and test it with A/B testing. And a robot can roll it back if things go bad. This is a lot of code that you will have to write. I'm sorry. But what can we look at for ML jobs during our validation? We can look at the CV performance, test set performance, convergence rate, number of features changed in selection, and depending on your model type, the delta in the weights. Cross-validation performance, you should mostly be familiar with it. It's not perfect. There are some cases where it's not going to give you good numbers. And your validation rules don't have to be perfect. That's okay. Just try and make them not terrible, right? That's all we need to aim for. Here's a bunch of related packages. I think they're cool. I wrote some of them. Other wonderful colleagues wrote the other ones, and some strangers wrote one of them. So they're pretty great. There's a bunch of books on Spark. I'm going to focus on high-performance Spark. It has absolutely nothing related to this talk, but that should not stop you from buying several copies. Yeah. Oh, and if you're interested in sharing the magic of distributed computing with children, I am working on an upcoming children's book called Distributed Computing for Kids. The last people that I told about this thought it was a joke, because I tell a lot of jokes, but this is a real project. Please give me your email addresses, and then I can tell you, and you can also tell me what age range you want me to target, because I've got an idea, but I'm flexible if people are. I'm probably not going to make this for 4-year-olds, but if there's a slight difference. Okay, okay, thanks, bye. I think I'm out of time on the nose. But I will be outside, and you can come ask me questions.
Yes, if you have any questions, we're out of time. Holden will be outside. Please follow her, and I can ask her anything you want,
yes.
Especially about distributed
like you're very
kids.
Happy while I take a photo of you for my boss. Sorry. Yeah, there we go. Yes, very happy. Very good. Okay, yes, that's the still being employed photo. Thank you.